Hello, this is a learning video in which you are going to learn how to name and how to draw branch alkyl groups and halides. So the first thing we're going to look at is what is an alkyl group. And an alkyl group is a branched carbon. They can be one carbon branching off of a long chain, or it could be two carbons branching off of a long chain. Here is a table that has the most common alkyl branches that you're going to see branching off of a long chain. The naming is slightly different. You'll notice that we have it ending in YL. So one carbon, which would have the prefix meth meaning one, YL meaning that it's an alkyl group. So it's called methyl. You'll see here that I have the structural formula with the hydrogens in attached, but we can also look at the skeletal formula, which it would just have one carbon branching off of a main chain. So let's take a look at some examples of what that would look like. Here is the first example. You'll notice that you have the name 2-methyl butane as written right here. The first thing that I take a look at is that I notice that the last name is butane. And butane, you should know by now, means that there are 4 carbons and they are all singly bonded. So this is the structure for butane. Then to write the structure for this 2-methyl, methyl means that there is one carbon branching off, and the 2 here means that it is on the second carbon of the butane branch. So that would be the structure for 2-methyl butane. If you drew it like this with the 4 carbons and then you had the methyl group going up on that second carbon, that would be the exact same structure. So you can place that methyl either in the downward position or in the upward position, that carbon. They both are exactly the same structure. Now if I asked you to calculate or to write the molecular formula, you're going to count all of the carbons that are in that molecule. Notice you've got 4 carbons in the longest chain and you've got 1 branching, so you have a total of 5 carbons. So that would be C5H12 because it is still an alkane and it follows that general rule, C to the N, H to the 2N plus 2. All right, let's take a look at another example. Here you have 2-methyl, 3-ethyl hexane. Again, hexane would be the longest chain, so you're going to draw 6 carbons. And then you will start placing your ethyl or alkyl groups. So the first one that I'm going to place is that 2-methyl. So you're going to have a carbon right here. And then the second alkyl group is 3-ethyl, and you would place a ethyl, meaning that there's 2 carbons branching off of that longest chain. And that would be 3-ethyl hexane. Its molecular formula, since it's an alkane, you still count up all of your carbons. You've got 6 in the longest chain, 7, 8, 9. So that would be C9H20, because it still follows that general formula for an alkane. Let's take a look at another example. Here you have 3,3-dimethyl-1-butene. You look at that last name, 1-butene. 1-butene tells you that there's 4 carbons. So I'm going to draw my 4 carbons. Here's my 4 carbons for 1-butene. 1 meaning that the double bond, and I know it's a double bond because it ends in ENE. 1 meaning that that double bond is between the first and the second carbon. Now something interesting happens here because we have a 3,3-dimethyl-1-butene. And when we look at that 3,3-dimethyl-1-butene, the di here is telling me that within this whole organic molecule I have 2 methyl groups branching off of this molecule. The 3,3 dimethyl. Di meaning that there's two methyls branching off of the whole molecule. The 3,3 here represents the position at which those are branching off. So I would place an alkyl here on the third carbon and an alkyl there on the third carbon. This is called 3,3-dimethyl-1-butene. Now there's also something else you should note here, is that because this is a double bond here, this first carbon has the priority because you want those multiple bonds to have the lowest number possible. So this is first carbon, second carbon, third carbon, fourth carbon. The multiple bond always has the priority of having the lowest number in front of its name. All right, the molecular formula for this structure would be, let's see, let's count up our carbons. It looks like we have 6 carbons total, so that's C6. And it is an alkene, so that follows the general rule of C to the N, H to the 2N. So that's going to be H12, and that is the molecular formula for 3,3-dimethyl-1-butene. The last example that I have here is a hexyne. So we're going to look at 2-hexyne. Hexyne means that you have 6 carbons. So here's my 6 carbons. I'm going to just kind of move it over here where I have a little space. 1, 2, 3, 4, 5. I need one more. There are my 6 carbons. The 2 tells me that the triple bond, and I know it's a triple bond because it ends in YNE. That 2 tells me that the triple bond is in between the second and third carbon. So there I am. I'm drawing my triple bond. And then when I look at what's in front of it, the 5-methyl means that on the 5th carbon, so that would be 1, 2, 3, 4, 5, on the 5th carbon, there is a methyl group. The molecular formula for this structure, since it's an alkyne, looks like we have 6, 7 carbons total, so that would be C7, H, it would be H2 to the N minus 2 since it's an alkyne. So that would be 14 times, or 7 times 2 is 14, so that would be H12. That's the molecular formula for 5-methyl-2-hexyne. All right, so that's how you can go from a name to drawing a organic compound with an alkyl group. Next, we're going to talk about how you can go from a drawing to a name. And there are a couple of rules that we have here. The first thing you want to look for is the last name. And the last name is going to be the longest alkyl branch, or alkyl, or excuse me, not alkyl, the longest chain that you have. The second name thing you're going to look at is the branches, and those are written as either the first or the second name, as you kind of saw with the previous slide. And again, the multiple bond has the priority of having the longest number or the lowest number. So I'm looking at this picture of this carbon molecule here, and you may think that the longest chain is right here, where this is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon. That would be wrong. The chain is actually longer than 7 carbons long. You have to beware of the fact that this carbon molecule can bend, and what I call that in my classroom is snaking. Okay, so you'll want to, a good strategy is to circle the longest chain. So the longest chain for this molecule actually starts up here, and it goes and it bends down like this. So that is the longest chain for that molecule. This is first carbon, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, seventh carbon, eighth carbon, ninth carbon. So this longest chain is actually a non-name. All right, we're going to learn how to name structures like this. Okay, so the first thing we're going to look at is this structure right here on the left. Notice that there is a double bond, and although it's pretty light on the screen here, so I'm just going to reiterate or emphasize that that is a multiple bond right there. So the first thing that I'm going to do is I'm going to look at the last name. And I'm going to circle the longest chain. And that's pretty easy because it looks pretty linear there. That is the longest chain. And so this would be 1, 2, 3, 4, 5, 6, 7 carbons that I see in that box. So this would be 1 because the double bond is in between the first and the second carbon. And I said that there were 7 carbons. Let me just double check. 1, 2, 3, 4, 5, 6, 7. So that's 1 heptene. That's 1 heptene. Now you'll also notice that there is a methyl group branching off of that, and that is on the 3rd carbon. So it's called 3-methyl 1-heptene. The molecular formula for this molecule, since it is a double bond, an alkene, it would have the molecular formula of C8H16. That is the molecular formula for 3-methyl 1-heptene. Taking a look at the molecule on the right, and again I'm just going to re-emphasize that there is a multiple bond right there between those 2 carbons there on the end. Now you may think that the longest chain here is 1, 2, 3, 4, 5, 6, 7, like here. Now notice, did you notice why I started counting over here as 1, 2, 3? That's right, because you want that multiple bond to have the longest or the smallest number possible. But this is not the correct longest chain, because if we, actually we're going to erase this, and if we incorporate here and bend down, that is the longest chain. And you'll notice it's 1, 2, 3, 4, 5, 6, 7, 8 carbons. With 8 carbons, you have a name of octene, and the bond is in between the first and second carbon, so I'm going to call that 1 octene. Now I'm going to look at where the branches are. Notice that I've got a methyl here, a methyl here, and a methyl here. And they are positioned on the 2, 3, 6, and there's 3 methyls within that whole molecule, so I call it a trimethyl. So 2, 3, 6 trimethyl 1-octene. Again, it is still an alkene, so its general formula would be C, let's see, I've got 8, 9, 10, C11, H22, because it follows that general formula of C to the N, H to the 2N. And if you don't remember that, you're going to want to look at an earlier learning video about general formulas. All right, let's take a look at this structure right here. Okay, looking at this structure on the right, we're going to want to figure out the longest chain, and it actually is right here. So that is the longest chain. And then I write the name nonane. Next we have to look and evaluate the methyl groups. So here I notice I have 1, 2, 3, 4 methyls. So that's a tetramethyl when you have 4 methyl groups. And their positions are 3, 3, 4, 5, tetramethyl. I'm going to kind of move that over. Let's see if I can kind of move over this nonane so we get some space here. And then you'll notice that the last alkyl group to name is this right here, and that's an ethyl branch, and that is on the 6 carbons, so that would be 6-ethyl. So 3, 3, 4, 5, tetramethyl, 6-ethyl, nonane. And the molecular formula for this, you count up all the carbons. I counted 15. It's a nonane, so that's C5H32. The next problem will be on the next slide, part 2, so you're going to want to look at the next video.